In Creo Parametric, you can define the milling sequences in order to machine a part. And I want to give you an overview of that. I'm going to show you a couple operations, each one consisting of a handful of milling sequences in order to create some of the geometry for this part. And I'm not going to do all of it, but again, I just want to give you a flavor of it. Before we kick off our manufacturing model, I want to show you a few different configuration options. If I go to File, Options, and then Configuration Editor, here in my list of config options, first I'll show you that we have one for the post-processor directory that we'll use in order to generate our code that will drive a machine. And also down here we have a few dealing with the parameters, the tools, and the workcells that are used in order to define the CNC toolpaths. Let's cancel out of here. To create my manufacturing model, you can go to File, New, or use Control-N. I'm going to use the New icon from the Quick Access toolbar. Then in the New dialog box, I'm going to change the type of model to manufacturing. The subtype is already set to NC assembly, and I'm going to call this machine source, and I'll call it CNC. Call it whatever you want. You can fill in a common name. I'm going to uncheck this option to use the default template just to show you that my template is going to be in inches. PTC provides a few templates in the load point where Creo Parametric is installed, and later on in another video I'll show you how to create your own template with some stuff set up for you to speed up the process of defining these different toolpaths. This is good. I will click OK. And now I am in manufacturing mode. Let me make sure I'm full screen. And right now I'm on the manufacturing tab. In here, let's start out by first I am going to assemble my reference model. So from this drop-down list, you can either assemble it directly, you could use inheritance, or you could use merge. And since I'm just going to use that original geometry, I'm going to assemble the reference model. Here we go. Click the open button, and because of the config.pro option I have, when I assemble a component, it is attached to the end of my mouse, and then I can just drop it in here. And for locating it, since I don't have anything in here to begin with, I'm going to use the default constraint and then hit the check mark. And when you do this, it's going to automatically calculate the absolute accuracy. Manufacturing mode is one of those areas where you do need to use absolute accuracy as opposed to relative. And I'm happy with the default value that it gives me, so I will click OK. And so now that I've got my part placed, the next step that I'm going to do is define my workpiece. And from this drop-down list, you can do an automatic workpiece, you could assemble one, and here you have the options to inherit or merge a workpiece or create one manual. I like to use the automatic option because it's going to give you a preview around the model. And first off, for the width of this, let me change this to a value of 9. And this length dimension, let's change this to a value of 12. I accidentally did not have my number lock on. Let's see, for the height of this, first off, I'm going to change let's plug this up to a value of about 3. And I'm going to make the offset from the bottom here 0.75 based on some dimensions from my fixture. I just want to make sure that we've got some material to grab on down at the bottom. And for the overall height of this, let me crank it down a little bit. 3 1/4 should be good. Just want to make sure that this is 0.75. To show you some of the other different things that you have for automatic workpiece creation, instead of creating a rectangular workpiece, you could start off with a round workpiece. And right now we have custom or envelope. Here we have placement, options. Here is just another different location for the different values that we have in here. And I'm just not getting the value that I want. All right, that's good enough. Let's hit the check mark. And your workpiece is automatically shown in a green transparent color. The next step in our setup is to define the work cell that we want to use. From the drop-down list, you can choose whether you're going to do mill, mill turn, lathe, wire EDM, or use a user-defined work center. I'm going to start off and just show you mill to begin with. If you do that, you have this dialog box where you can give it a name, and then you have the type in here, choose the number of axes, what post-processor it's going to use, so forth and so on. A bunch of other different tabs inside of here. I'm going to cancel out because I have a few predefined work centers that are pointed to by my config.pro option, so I can use that instead. So work center, user defined work center, and here are some of the different ones that I have in here. Let's use the Mazak and click the open button. And by the way, these different work centers are user defined features. That's why they have the .gph file extension. So I will click OK. And for the Mazak in here, if I choose edit definition, we see in the dialog box that this is a 3-axis mill. Let me click OK to get out of there. Now that I've got my work cell in here, let's define a fixture to hold this. So I will click fixture, and from components, I can click on to add a fixture component. I have a folder that contains an assembly that I want to use. Let me drop this in here and just start to position it a little bit the way that I want it to be. And now I can start doing constraints. Let's use this surface and query to the bottom of the workpiece. And right now those are coincident. That's good. Let's pick this one and this one. And lastly, I'll pick this flat surface and this flat surface. And everything is adjusted and I am fully constrained. Now, one thing I have on my wish list from PTC is to enable flexibility so that I could have a fixture assembly with component flexibility, and I could adjust, for example, the dimension for the location of the slide based on the size of the workpiece. But I don't believe that is on PTC's roadmap. We can all hope. All right, for component placement, let's hit the check mark, and now we're back to the fixture setup tab, and we can see it on here. There are a couple other different tabs for process if you want to plug in the time that it takes for this, and if you want to rename the fixture setup, you could do that. Let's hit the check mark, and there we have our fixture setup located inside of here. And for the next step, I am going to define an operation. So let's click on operation over here. And one thing that needs to know is, where is my machine 0 for this particular component? And while I'm inside of here, if you take a look on the right hand side of the ribbon, you have a couple of drop down lists. Later on, I'll be showing you how to use some of these for creating different manufacturing geometry. But from the datum drop down, I can create a coordinate system for my machine 0 on the fly. And let's select our vertex to locate it. Now for the orientation, we want our Z direction pointing up. So I'm going to pick this, make sure I click in the correct collector. We want this surface to define the Z direction. And I prefer to use surfaces as opposed to edges. You could pick this edge to define one of the other different axes, or if I pick this flat surface, the normal to the surface will drive that direction. I actually want that to be the X direction, and let's click the flip button. So now I've got my coordinate system oriented the way that I want. And from the properties tab, I'm going to rename this, and this is going to be for my 010 operation. It's going to be my 0, so I'm going to name it appropriately and then click the OK button. And now when I resume the dashboard, it automatically uses that coordinate system as my machine 0. Now let's go to the clearance tab over here. Right now there is no clearance, and instead I can choose to use a plane For the plane reference, once again, I can create a datum plane on the fly. And this one, let's have it, I'll do an inch off of my workpiece as the retract. And let me go to the properties and again, rename this. I'm going to call it OP operation 10 and retract. And click the OK button. Once again, we will resume the dashboard for the operation. Let me go to clearance, and here you can see that my plane is located in there automatically. Here we have a checkbox to always use the operation retract, and let's go to fixture setup. Right now for this particular operation, it doesn't have a fixture setup, so let's select the one that we previously configured, so that way we have a reference assembly that we could use for gouge checking and other steps later on. So this is good for setting up the operation. Now we will hit the check mark, and we've got everything set up to define some different sequences. I now have a mill tab on here that allows me to create my different operations. And in my 0-10 operation, I'm going to have 3 different milling sequences. And right now I've got a little bit of stock above the top surface of the part. So let's do a facing operation to remove some of that geometry. So we will click face over here. And right now it doesn't have a tool listed. So we can use the drop down list to choose edit tools. And I don't have any tools listed in here. I didn't do any tool setup earlier, but I can take care of that now. I will click the open button. Because of my config.pro option, it takes me to a folder where I have a bunch of different solid tools. And solid tools are ones in which you actually have components that are used to define your geometry. You also notice that we have XML files for defining this. So I'm going to select these different ones, and let me hold down the shift key to grab this. Actually, let me grab just this one over here. I can add the other tools in later. I'm going to use the 3-inch facing tool. So let me click the open button. And 1 second, I have a kitty who has joined me here. So there I have the tool that I'm going to use for this particular operation. And again, this one has geometry associated with it. And I like this because of the way it looks when I am playing the different paths. Just be aware that when you are using solid tools, this can have effects like, I believe that material removal features don't work when you are using solid tools. And this one is already set up for a particular material, and you can set the tool number and the offset number for where this particular tool is located. And right now we don't have any cut data listed in here. You can set up this other stuff as well, but I don't have it set up for this particular tool. When I click OK, you'll notice that it says, hey, we can update the sequence parameters that are going to be used in here by copying the cutting data from this particular tool. So I will say yes to that. And let's go back to the reference tab over here. For the machining reference, it needs to know what I want to use, what surface to use as a reference. And on the right hand side of the dashboard, if I go to drop down over here, here's the different kinds of milling geometry that you can create, like a mill window, a mill surface, mill volume. And right now the drill group is grayed out because that really only applies to hole making sequences. But I'm going to create a mill surface. And now on the mill surface tab, I have a variety of different methods that I could use to do that. You have your extrude, revolve, sweep, swept blend. I'm going to use the fill tool to create a flat surface. And right now for the sketch, we can define a sketch inside of here. For the surface, I'm going to query to the top surface of the reference part. Then click the sketch button. And I'll use the project command in sketch mode and use the loop option. and then pick this surface over here. So I'm just grabbing the edges of the workpiece to define my mill surface. By the way, one interesting thing, you'll notice that I'm like many different tabs deep in terms of the nesting that I'm doing for creating my geometry. Let's hit the check mark to get out of sketch mode, and everything got clicked. I had a kitty just run across my keyboard. All right, so we create the mill surface, and then we can hit the check mark out of here, and then we can resume the dashboard. You can see a preview of the sequence that's going to be created inside of here. If I go to the parameters tab, be aware that here we have the different basic parameters. You could use the open button if you already had some predefined parameters defined, which I have in here, but I'm not going to use these just because some of my milling parameter files are a bit old and some of them have incorrect parameters in here. Let me cancel out. You could use this button to open up the edit parameters dialog box, and right now it's just showing the basic parameters inside of here. If you click the all, for some reason it's not giving me that, but here are all the different parameters that you have available. There's also a drop down list if you just want to do, hey, feeds and speeds. I want to go and adjust these different values inside of here. Oh yeah, here's basic. They're how you can toggle between the different ones in here and go back to all categories. So lots of control that you have over your particular sequences. Let me click the OK button out of here. Everything looks good. I can hit the check mark, and I'm going to hide my geometry. When I do that pretty quickly in the operation, hiding the different geometry. And now let me click on the face milling sequence. In the mini toolbar, I can choose to play the path. And again, this is the main reason why I like using solid tools. I think it looks kind of cool, but again, really not necessary. You can configure tools, and I'll show you how to do that in another video. Here we have the play path dialog box. Here is the cutter location data that it's going to use to run this. Later on, we will end up converting this into our actual machine code using a post processor. And if I hit the play button, that went by really fast. Let's slow it all the way down and then hit the play button. Oops. There we go. Just played it in reverse. Here you can see that's the path that's going to take for that facing operation. And I could configure different things like the step height that it does, and I could have multiple different passes done, but this is good for showing you the face milling sequence. Next up, we'll take a look at doing a volume milling sequence in order to remove a lot of the geometry. And actually, before I do that, I'm going to create some other construction geometry just to help me do it. I happen to know that the shape of this is a little weird, especially around over here. So I find that it helps if I create a cross section and then a curve from a cross section going through the edges of the rounds. So again, this is stuff that you normally don't have to do, but I'm doing it just to facilitate this particular operation. And I'm going to query to this particular edge over here, and I'll just call this my construction plane. Hit the OK button, and now I'm going to go to the View tab and create a planar section through there, and that is good. And I'm not going to bother changing the name. The only reason I have this cross section is so that I can go create a datum curve through that cross section. And there we have our curve created. Let me disable this cross section, and it might be hard for you to see, but in blue we have a curve there that I'm going to use for defining my mill volume for my volume milling sequence. Let's go to the mill tab. Now I'm going to click on the volume rough command, and for my reference I'm going to use a mill volume. So to create the mill volume, again, I'm going to go to the geometry drop down over on the side, and here we have the mill volume command. And I'm going to do an extrude. And for the sketch, let's define it. I'm going to locate it on these different tabs here. And let's click the sketch button. Now in sketch mode, for my first group that I'm going to use, let's use the project command. And I'm going to use the loop option again and pick that top surface so I can just grab all the outside edges of the workpiece. For the other edges that I want, I am going to use the offset command, and I want to offset a little bit off of that curve that I created. So let me make sure that I get down here. There's one curve segment. Let me use the control key to get the other segment of the curve and click the next button in order to highlight all of it. That is good. Let's click the accept button. And I want to offset to the outside, so I'm going to do a negative 0.25. Offset a 1/4 inch off of there. That's good for that. Let's hit the check mark because I'm done with my sketch. And so there you can see a preview of the mill volume. Let me right click over the depth drag handle and change the depth to selected and just pick, technically I should pick the top of that mill surface I created before, but for simplicity I'm just going to pick the top of the workpiece. So that is good. Let's hit the check mark, and there you can see my mill volume. And right here, even while I'm in the middle of constructing it, I can hide access. Hit the check mark to complete the mill volume. Now I'm going to hide it because it's blocking my view. Let's resume, and for the reference, for the machining reference, let's use our quilt. And let's see, for the tools, from the drop down list, I'll choose to edit the tools. And for this one, I'm going to use the open button in order to grab my ball end mill 1/2 inch. Click the open button, so there's what the tool looks like. And once before, we can click the OK button. And yes, we can update the sequence parameters by copying data from the tool. If I want to adjust any of the other different parameters, I can. So for example, maybe for the cut speed, I want this down to a value of 160, and my spindle speed is way too high, so let's reduce that. And again, I could change any of the other different parameters, but I'm not going to. Let's hit the check mark, and there we have our volume milling sequence created. I can click on it and play path from the mini toolbar. Let's give this a few seconds for calculating. And there you can see it located. And let's hit the play button. And we can see its progress as it's going through here. It's going very slowly, so let's just speed it up. And so there you can see the paths that are being taken by this particular volume roughing sequence. And let's click the close button out of here. We'll do one more inside of this particular operation, and for the last one, we're going to do some profile milling to clean off some of the material from the vertical edges. To create the profile milling sequence, let's click on profile milling, and for the geometry I'm going to use in this case, it will be a mill surface. Let's go to the drop down list and choose mill surface like I did for my first face milling sequence, except this time I'm going to do an extrude. And like before, let's define our sketch. I'm going to locate it on those same pads I did before. Hit the sketch button, and let's use the project command. I'll use the chain option so I can grab those curves that I created before. There we go, that's the loop that I want. Let's click the accept button and close, hit the check mark. And for the depth, just like before, I'm going to change to selected and pick the top surface of the model over here. and hit the check mark. And so there you can see my mill surface that I'm going to use. Let's now go to hit the check mark to complete that, resume the dashboard, and I'm going to use the same tool that I used before. And now we can hit the check mark to complete that. Let's hide the mill surface, and that way I can now click on this and choose play path. And oops, it's giving me a problem with the path. Let me edit definition, go to the reference tab. I never selected the machining surface. There we go. Let's hit the check mark and play path. Now it's calculating, and maybe put the speed down a little bit. And there you can see the path that's taking as it is taking that last 1/4 inch of stock off of the side pieces. And close out of here. And so in that way, in my first operation, I have 3 different sequences that I created. In the next video, I'm going to show the second operation where I'm going to basically flip the workpiece over and do a few operations on the other side, including a facing sequence, roughing, re-roughing, and a hole making sequence. I hope you enjoyed this overview of the manufacturing process. For more information, please visit www.creowindshield.com. If you learned something from this video, please give it a thumbs up. And if you like this video, please click the subscribe button to be informed when new videos are uploaded. Thank you very much.